just manually entering metadata, or you can have an intelligent system that trawls the web and recognizes the information and then records that as metadata. But how do we incentivize actual experts in the field to record their ideas, their understanding, their choices in areas where normally they wouldn't do that? How do we create systems which are designed to produce semantic metadata as exhaust? So we let users do something they want to do, they're not worrying about metadata at all. It's not that we're consciously giving them incentives. They do their job, and as a result, we know what it was they were doing. And you see that this methodology helps achieve goals like that. Another question is user acceptance and adoption of any model we have. Metadata is expressed in terms of some kind of model. How do we design this model? What's the underlying taxonomy, ontology, whatever it is? Well, we get the knowledge engineers hacking away at their ontology forever, and then you give it to some users, presumably the domain experts that helped these knowledge engineers develop the model will be okay with it. Then you show it to other people, and they say, no, I'm not interested. This doesn't reflect the way I'm thinking. So how do you really create a model that users accept and adopt? People will always have disagreements with it. People will never have complete people will never agree with each other on every idea, but how can you get them to feel close to it, and that they like it, and that this is meaningful for them? And finally, we're talking about a model which metadata is expressed in terms of how can this model be useful for users to communicate with each other? More and more we're building models that are for the use to be used by computers. We're generating metadata in a technical way that then is used by some technical system. How can we keep on focused on users actually being aware of the metadata and aware of the model and using that to say things to other people? And there are two different cases here. How can you have technical experts and domain experts communicating with each other? So how can you put people from different fields together so that the software engineers can understand exactly what the librarians or the film directors want? And the other case is how do you actually get actual end users communicating with each other? So the methodology I want to talk about is related to all this. And the fundamental idea here is that we see the process of developing a visualization as part of the process of developing a knowledge model. So it's important that the wording here is important. I'm not saying that we use user visualization to help educate, let's say, the end users. We're not just showing information in a visually appealing way. We work with domain experts to develop a visualization system. This can be a diagram, or it can be a picture, and if you have 3D experts and a game company, it can be a serious game. Doesn't matter how graphically interesting it is. Even domain-specific language, a text-based language fits in here, although you wouldn't really call it a visualization. But some way of looking at a screen and having a conceptual idea, normally visual, that's why I'm talking mostly about visualization, and getting a message across, expressing the conceptualization, expressing ideas, expressing choices, for example, for the example case of film directing that I'll talk about. So there's some underlying principles here that are quite interesting. There's some interesting discussion about cognitive effectiveness of visualizations. There's a general assumption that if you show something to people visually, they'll understand it better. But that, of course, isn't the case. If you just have a bad visualization, that can confuse people. So the idea is you have to design a visualization to really communicate effectively. Now, the interesting thing is that it's not just about it being easy to read the visualization, look at the pictures and know what they mean. It's also about the logical correspondence between the structure of the visualization and the structure of the domain. And we're often talking about tacit knowledge. So people are very good at intuitively understanding ideas through a visualization, even if they don't have a conscious understanding of these concepts. So they couldn't just write down a taxonomy of concepts that corresponds to the domain, but they can still intuitively understand how well a visualization corresponds to this underlying structure. So by developing a visualization with domain experts, that gives us access to tacit knowledge that is there, that is very hard explicitly bring to the fore just by writing concepts on a piece of paper, doing more traditional knowledge acquisition tricks like card sorting and so on. Another key issue is situated cognition, which I read about fairly recently, but it's interesting because it fits right into the way we are working. So the idea here is that, well, the way we think is context sensitive, that's nothing new. But the way we explain how we solve a problem is quite a tricky thing. We often don't understand how we really think about an area, we really don't understand our own intuition, and we're very good at coming up with a nice narrative to fit back onto how we solve the problem afterwards in order to explain our solution. And that isn't so good for creating a knowledge model, and the metadata that we then extract based on this knowledge model is going to suffer. So we really want to work within a context that helps us get over this, that helps us focus. We need to have a mechanism that brings the context to the fore and exposes the mechanisms of what we're trying to do, so that we don't get trapped in this process of explaining what we did in an accurate way. Right, so time to go to some pictures. I'm going to skip all this. I don't know what it is. The major application we've had so far is film directing, and you're not supposed to understand this. So the idea is that a professional film director would take a week to understand how this works. I'm not going to explain it in 30 seconds. But again, it's not something you need to do a PhD to understand. It's something that you learn in a seminar. So what's the idea? A musician can compose and write down music. We have a musical score, a partitura, I like to call it. And in the field of dance, there's something similar. It's much less known, but there are symbolic notations that allow you to logically record human movement. That's very impressive. Not very well adopted because there were never technological tools developed to support it, and it's very hard to read. But we said, why don't we do the same thing for film directing? So a director can actually write a score representing a film. And there's always the question of interpretation. This isn't an animation tool. There's always a level of interpretation where an artist is actually creating and takes creative liberties. So in the same way as a composer doesn't tell a musician exactly how to play a piece of music, this isn't a complete specification of an animation, it's documentation of film directing choices. And we followed this methodology that I've been talking about in the abstract. So I'm going to go through how we refined our model, and then at the end of the talk I'm going to come back and look at these incentives that I mentioned, like the things we want to achieve with metadata. So I mentioned that we had a project that started in 2008, but I've been thinking about this from 2005. So there already was a crude notation. We're not going to explain any of the notation, but we said, okay, we've got some constraints, we'll create some kind of visual representation, put some symbols on it. So, and this means some things. And this corresponded to some taxonomy that we had in mind. I'm not going to go into any of the logical constraints, I'm just going to show the taxonomy in these examples. It's quite enough. So we got our actual professional film directors on board a few years later, and we explained to them how this worked. And in the beginning they weren't sure, they were just learning, and we said, okay, this thing here says how far the camera is from the actor, right? Sometimes the camera is close to the actor, sometimes it's far from the actor. They were saying, yeah, okay, we can do that. They're not disagreeing right from the very beginning. We're still teaching them. And this other symbol shows in which direction the camera is filming. This other one shows how it's moving. Yeah, okay. And we've got this initial little taxonomy and some obviously more constraints that we have in mind that I'm not showing, and we're going to validate it at an initial level. Now, what we eventually want to do is we want to describe the whole film and try to go and get an animation, for example. So in the beginning, we certainly don't have any animation tools that are working, but we can do mock-ups. We start having sketches, we write symbols by hand, the editor isn't ready either, and we draw what we might see, and we talk about what's interesting. Now at this level it becomes important because what really is interesting? There are all sorts of concepts that domain experts are working with, but how do they want to see it? What do they want to express? We come up with really tricky questions like, actor starts there, actor has to end there, the director just says, okay, go. Now we've said that there's a table in between, somewhere else we have set and location notation. So do we want to have a path-finding algorithm that creates an animation where the character goes around, or is the director just saying, okay, actor goes from A to B, go from A to B, we see an animation of the actor going through the table. The absolute answer, but the second the actor goes through the table, it could be a ghost, right? We're not creating an animation tool. We're creating a tool to take ideas and put them down, right? This is coming back to metadata. If you're annotating a film, and then you pull this information and store it in a database and attach it to the video file, what do you have? You have the choices of the director, what they were actually wanting to do. If you had a pathfinding algorithm adding stuff, then you'd have a different film and different ideas perhaps. You'd have an algorithm making choices. But over here, the idea is we get exactly what our domain expert is interested in, express it, and express it in a formal system that we can then store, where we can then store our data and it's machine processable. So, working with mockups like this, initially we add some concepts. We say, well, when we were actually not talking to film directors, we never bothered about focus or depth of field or the angle from which we see a subject. This is, of course, very important. So we had some concepts. And in general, in the initial phase, we went very well at elaborating the physical movement of objects around the stage. When we got to framing, things got complicated. And there's a nice story about this. So this is actually a text-based representation of some of these ideas. The story is, we were stuck. It was quite hard talking about where something appears on the screen, how these are related, what is in negative space, do we want to represent negative space? So the nice story is, we were stuck and we had a coffee break and the film directors were out drinking coffee and a couple of us engineers were sitting there saying, okay, how are we going to do this? And we started writing in this sort of style with our little parentheses and sort of pseudo AI syntax, whatever, prologue, not quite. And after the coffee break, the film director came back and looked over our shoulders and said, that's wrong. And he said, don't look at this. You can't understand this. This is like, computer science stuff. It's not for you. These were people when we said 90 degrees, and they said, please no mathematics. Okay? These are not scientists. And they look at this and say, no, it's wrong. What do you mean you understand this? It's, well, yeah, of course, the body part is the right hand, and it's making a gesture like there. No problem, I understand this, and it's pointing. And so the fact that we had these people in a structured conversation initially about symbols, which we were trying to change and make them to be the symbols that the directors wanted, got them into a frame of mind where they're thinking in a more structured way, and at the same time they're imposing their structure on us. We're not creating a structure that tries to approximate what they're telling us in an interview. They're imposing their structure on our work. And so we realized, using FDL, frame description language, that framing is really important. Then we have to start talking, we create various new concepts and categorize them under framing. These are framing issues. And we're trying to draw this now with symbols because this thing is completely useless. You can't actually use it. It's an internal artifact of the process. And we realized, well, the fact that we grouped a bunch of concepts in a taxonomy under the framing concepts means we can draw them separately. So we have changed the way we're drawing. So what this illustrates is that we are really adapting the way we work to what the domain experts are telling us to do. We group the concepts differently, we change their values, so we are really working on the ontology in depth, which the domain experts understand. If you give them a protégé file, they don't understand it, but we have a representation for them with a one-to-one correspondence to this ontology that they do understand, better than us, in fact. And eventually, we really modify our taxonomy as well. So this framing element has been moved up in the hierarchy because it's more significant. And this really changes the way we model the whole thing. We had to completely throw away a whole lot of constraints that were underlying here and remodel, well, change our model, basically. And I think that's the end. So I've spent most of my time, but go back to metadata, which is what we're supposed to do, when this results in an authoring tool, like this, you have domain experts who are doing their work. They are writing down on a piece of paper hopefully not on the screen, and when they're using an editor and not paper, that's all you need them to